we are entering into a time frame that we don't know what the future vehicle is going to look like. Therefore, it is very, very important the vehicle designer actually work on the design, the architecture of the vehicle, and using the materials, using the tool they have, which is the predictive capabilities, and working with the steel manufacturer to see what kind of material they can produce. We need to start thinking outside the box. The vehicle maybe not so squarey, not so kind of rectangle shape, and maybe it's more kind of rounded. And so you're gonna have a lot of new innovative design feature coming into the vehicle for the future and using different technologies. So there is increasing effort currently in the research community for developing the future advanced high-strength steel. So these materials have ultra-high strength capabilities, but also has certain ductilities, so it will not prematurely fail or fractures unexpectedly. When we work with this, we want to work with engineers in the automotive industry. We also want to work with steel manufacturers to understand how to achieve these type of design performances. In order to improve the fuel efficiency and the vehicle, it become lighter. Okay, so when it become lighter, and it'll still have to protect the occupant inside. So it is very important to have advanced strength material to replace the traditional mild steel or standard steel in order to achieve the lightweight. It's no longer just a commodity provider to provide the steel. It's actually an integral part of the entire ecosystem for provide the transportation, provide the vehicles, and you have to work with the industry, look at what the future demand is, and have the flexible capability of design different feature material to suit different needs. You can no longer just provide 2 or 3 different steels for the entire car. You have to provide multiple of those. And then in the future, in order to design these vehicles, you need to have many different type of grades. So vehicle manufacture will be, I think it will be smaller in quantity, but more in variety. The thinking is that you will have vehicles driving into a certain area and you can park, or you can take the light rail into the city, and then you have autonomous vehicles, and in these vehicles will be on demand to transport people around. So I think we all can agree today, if you have a very large parking garage in the city, it's a waste of space, and it's produce traffic jams. We're probably going to have 4 to 5 different phases of autonomous technology. So today we have a vehicle has some kind of autonomous features. It can drive by itself, follow the vehicle in front, and has some kind of accident prevention technology. So then in phase 2, the drive still have to sit there and to monitor it, and so they require the drive to fully participate in that. So we are in the stage between phase 1 and phase 2. But when it gets into phase 3, the vehicle actually should be able to drive itself. In the next 4 to 5 years, you will see a mixture of a newer design of vehicle, different type of driving systems coming into play, and then using advanced materials. You will see more of collaboration between cross industries, and then you will see people in the vehicle engineering people will be communication with the steel manufacturer engineers and material developers, and then you were at the same time you were talking about IT engineers, algorithm developers, and they all gonna have to work together to make this happen.